What's up, guys, and welcome back to another video from the Scalar Learning channel. Today we are talking about verifying trigonometric identities and essentially showing in these equations that both sides are equal, okay? And to solve these, what you must rely on is your knowledge of all these various trigonometric identities. Now to the left, I have a little cheat sheet of trig identities that I put up on my Instagram page. Again, to go to Instagram, just look for the Scalar Learning page and you can find this as well. I just posted it very recently. And you can use that as well. Now, depending on your teacher, you're gonna eventually want to commit these to memory, but for the sake of this video, in terms of explaining and how to solve each of these, I'm going to have it up there so you can see which ones I'm referencing. And we're going to step through each one of these and I'll show you how to solve them. Now again, the preference of most schools when they want you to do these is they want you to take one side and one side only and manipulate that one side to equal the other side to show that they're both equal, so I will follow that protocol. All right, let's do it. Number one, we've got sine plus cosine theta times cotangent theta equals cosecant theta. So again, the general strategy is to start with the left side, which is usually the more complex side, side with more stuff on it. So let's go ahead and try and manipulate it. So the first thing I'm looking at here is I see that sine. I'm going to kind of leave that alone for now. And then I see I've got cosine and cotangent. Okay, my first instinct is to turn that cotangent into, cotangent is really cosine over sine. Okay, so if we're multiplying this and right, I can take that from right over here. We said cotangent is really cosine over sine. Okay, so that's pretty cool. So now if you'll notice, what I have is I have cosine times cosine over sine. So really, what is this? This is that sine theta is going to stay right there. I'm going to put it over 1 just because I see I have a fraction coming in here. Now I have cosine times cosine, which is cosine squared theta over sine theta. And this equals, again, cosecant theta. Now again, I'm looking and I'm seeing I've only got one trigonometric function on the right hand side. I got kind of broken up into two pieces here. Let's get these together, aka let's get a common denominator. So I'm going to multiply the numerator, let's make that into a sine of theta, denominator and the numerator by sine of theta. Now I have a common denominator, but check this out. I have sine times sine, which is sine squared theta. And you should already be thinking this looks pretty good, because when I have a sine squared theta and a cosine squared theta, I'm thinking about a very important identity. Okay, next we can now combine these guys, right? We can just simply add them and throw them together. So now I have sine squared plus theta plus cosine squared theta over a common sine theta. Sine squared plus cosine squared is actually 1. Right? That's right here, the Pythagorean identity. Sine plus cosine squared, sine squared plus cosine squared is 1. So it's 1 over sine theta. And 1 over sine theta is, of course, cosecant of theta. And we've done it. Immediately when I look at this one, I'm seeing a difference of squares. Okay, so that's the first thing that's popping in my mind. Don't abandon everything you've learned with quadratics. So if it's a difference of squares, well, I'm going to turn it into, I'm going to basically factor it. So it's going to be sine squared x minus cosine squared x times sine squared x plus cosine squared x. Okay, and that equals the right hand side. Now it's kind of looking a little bit more interesting, because again, what did I say? Sine squared plus cosine squared is 1. So for all intents and purposes, this is 1 times that, which really means it doesn't matter anymore, right? 1 times that is just that. Now it's looking a lot better, right? Now I have sine squared x minus cosine squared x equals this whole thing. Well, now again, I'm going to use one of my Pythagorean identities, because I see that I only got cosine squared x. I don't have any sine squared x, but sine squared x plus cosine squared x equals 1, which also means that 1 minus cosine squared x, right? If I subtract cosine from that side, equals sine squared x. This is our Pythagorean identity, which means I can take this value right here, plug it in for that. So now I have 1 minus cosine squared x minus cosine squared x. These guys kind of combine because they're both negative, so it's 1 minus 2 cosine squared x, and that's it. We've proven it. We got cotangent secant over cosecant equals 1. So very simple on the other side. You just have to prove that this whole thing kind of goes to 1. So I want to get everything in terms of like the same stuff, really. So first of all, I'm looking at secant and cosecant, and I got a cotangent. Well, what is secant over cosecant? Okay, well, luckily I actually have it right here. I have it in this one. It actually equals tangent of x. So guess what? I'm going to take this cotangent of x, I'm going to separate it out from the secant of x over cosecant of x. And then I'm going to convert that secant of x over cosecant of x based on this into tangent of x. But what else is interesting is cotangent is really 1 over tangent of x. Just like tangent of x is 1 over cotangent of x, doesn't matter which way we do it. So then I multiply these guys together, store a 1 underneath it. These cancel out, and now I have 1 equals 1, and that has been verified. Okay, number 4, again, I'm gonna go with this left side here. We've got sine of x over 1 minus cosine of x minus cotangent of x, and we want to get it all to equal this simple cosecant of x. Okay, the first thing I'm thinking is I've got 2 parts here and I've only got 1 part here. I need to consolidate these somehow. All right, my thing is let's get some nice common denominators. So I'm going to multiply this guy by 1 minus cosine x, 1 minus cosine x, right? So I got sine of x over 1 minus cosine of x minus cotangent of x times 1 minus cosine of x over 1 minus cosine of x. Okay, now it's looking a little bit better. Now I can distribute, and these are all going to merge now, right? So now I got sine of x minus cotangent of x, because that just multiplies with 1, and then plus, don't forget that minus sticks to that guy and distributes with it, so the 2 negatives cancel out, plus cotangent x times cosine x over this whole thing, 1 minus cosine of x. Okay, now this is still pretty interesting because, check it out, cosine of x can, cotangent of x can again be written as cosine over sine. So watch this. We're going to say sine of x minus, and I'm going to replace this into cosine and sine as well, minus cosine of x over sine of x plus cosine of x over sine of x times a second cosine of x. Now I almost see everything having the same denominator. Don't I want everything to have the same denominator? Yeah, then I can add everything together. So let's throw this over a sine of x as well. We're multiplying like that was a 1, right? Multiply by sine of x on top, so that becomes sine squared x, right? And we can really represent this cosine times cosine as cosine squared x. Okay, now we got a really cool thing. So now we're going to take up some of this room over here. We're gonna put it all, and that's all over still 1 minus cosine of x. So now I have sine squared x minus cosine of x plus cosine squared of x over sine of x all over 1 minus cosine of x. Now these again, look out for that sine squared plus cosine squared. Sine squared plus cosine squared plus cosine squared equals 1, right? So now I have, so these kind of cancel out to 1. So now I have 1 minus cosine of x over sine of x, again divided by 1 minus cosine of x. So if I'm dividing by 1 minus cosine of x, it's also like multiplying by the reciprocal of that, which is 1 over 1 minus cosine of x. Oops. And now these guys cancel out, and I have 1 over sine of x, which of course equals cosecant of x, and we're done. Now we come to number 5, and we got sine of x over secant x minus tangent of x. So again, let's manipulate this left side. I got sine of x over secant of x minus tangent of x. So what I'm looking at here is I've got a problem, right? I got 2 terms on the bottom here and I need to get 2 terms on the top. Kind of need to reverse everything, right? So the way that I'm going to approach this, again, there could be multiple ways to do this. This is the first thing I'm looking at, is since I want secant x plus tangent of x, my thought, and on the numerator, my thought is maybe I'm going to just multiply this guy by secant plus tangent of x. And that actually gets the secant x plus tangent of x on the top, which is pretty cool. So that's pretty good. Now what do we do about this bottom? This bottom's actually not looking so bad because it's essentially like a difference of squares factored out. When we FOIL the bottom, and I'm gonna leave this sine of x out in front, and I think you'll see why in a second. So if I FOIL this, I get secant squared x. Then I get secant tangent positive, secant tangent negative. Those middle terms cancel out as we have with the difference of squares. Then those guys multiply each other. Tangent times tangent is minus tangent squared x. Okay, and then on top, I'm just gonna leave everything like this, right? We got sine of x times secant x plus tangent of x. All right, there we go. Now, you always want to be looking and saying, hey, when we got secant squared and we got tangent squared, right? There's probably some identity that relates these. Could be not always, but a lot of times. And if I look over here, look at this. I got tangent squared x plus 1 equals secant squared x, which means that if I subtract tangent squared from this side, it's going to equal 1. So this here equals 1. So this is essentially gone, right? This turns into a 1. So now I have sine x times secant x plus tangent of x. And we're almost there because sine of x is the same thing as cosecant of x. So it's the same thing as 1 over cosecant of x. So I can literally rewrite this times 1 over cosecant, or same as throwing cosecant in the denominator, and we're done. Okay, number 6. So I've got these nice square values on the bottom. I've got not squared on the top. Immediately, again with this one, I'm seeing a difference of squares. So the way I'm going to take that is I am going to factor that out. So I'm going to factor out the bottom, tangent of x minus cotangent of x over tangent of x minus cotangent of x. Remember I said don't forget all your rules that you've learned from quadratics and factoring. And then that's tangent of x plus cotangent of x, right? So now look, these guys cancel out. This becomes 1 over tangent plus cotangent. 1 over tangent of x plus cotangent of x. My next clue in terms of what I do is I see I got sine and cosine. I don't have sine and cosine here. I have tangent and cotangent, okay? And also they have one term. So that means 1, I want to get this in terms of sine and cosine. 2, I want to consolidate. So that means I'm going to turn that into sine of x over cosine of x. Again, this is all underneath 1 plus cosine of x over sine of x. Now, how do I consolidate any common denominators? So I'm going to multiply this guy by sine, right? Now it's sine cosine. And then the top by sine has also become sine squared. This guy by cosine of x. So it becomes squared. Now watch what happens. This becomes 1 over sine squared x plus cosine squared x over sine x cosine of x. Now look, this is looking pretty good because this is the most important trig at any of them. All sine squared plus cosine squared is 1. So now I have 1 over sine x cosine of x, and then 1 over that is of course just simply, put it up here, sine x cosine of x, and we're done. Now we come to number 7, cosine of x over secant minus 1 minus, all this craziness. It's a complicated one. Now all we want to do is on the other side get that nice and simple cotangent of x, cotangent squared x, excuse me. So I look at these guys and I say, well, I probably want to consolidate these somehow. Okay, get them over one denominator because I only got one term there. And I see a secant and I see a tangent. So I'm going to take a look, and if you see, there's a nice identity that binds secant and tangent together in terms of squares, and that's tangent squared plus 1 equals secant squared. All right. This also means that if I subtract 1 from this side, secant squared minus 1 equals tangent squared. Wait, I can get that pretty easily, right? Because I got secant x minus 1, and if I multiply, I'm going to show you. If I multiply secant x minus 1 times secant x plus 1, okay, like this, if I multiply these guys, I'm going to get secant squared x minus 1. It's going to get a nice difference of squares. And I'm going to leave that guy alone for now. Cosine of x over tangent squared of x. Okay, but I have to also remember to multiply the top here by secant x plus 1. Okay, so on the top up here, these guys multiply. Cosecant times its inverse is of course just 1. Cosecant times 1 is just, cosine times 1 is just cosine x. On the denominator here, we get secant squared x plus secant minus secant, those cancel out, minus 1. And then over here we get minus cosine of x over tangent squared of x. Now again, I said secant squared minus 1 is just tangent squared, so I got 1 plus cosine of x over tangent squared of x minus cosine of tangent squared x. Now we got common denominators. These guys can combine the numerators. Obviously these cosines cancel out because it's minus. So now I just have 1 over tangent squared of x. But guess what? That means it's the inverse of tangent squared, which is simply cotangent squared x. And we're done. Number 8 is secant plus tangent over secant squared equals this guy. Again, let's take the left side. So what am I looking at? First of all, I'm seeing that I've got only cosine and sine, no secants, no tangents. So that's immediately telling me I'm probably going to want to get this in terms of cosine and sine. But the first thing I'm going to do is I'm looking at this secant squared, and since it's in the denominator, I can literally rewrite that as cosine squared theta. Like simply throw it to the top, because 1 over secant squared theta is cosine squared theta times secant theta plus tangent of theta. Okay, it actually looks pretty good right now, right? We're getting pretty close to that form. I'm going to do something a little unorthodox. I'm going to take one of these cosines, because this is really cosine theta, right? I'm going to take one of those cosines, not both, and distribute it. Okay, so now I'm going to leave one cosine theta on the outside, just like we have in there, and then I have cosine theta secant theta plus cosine theta tangent theta. Cosine and secant, they're inverses of each other. Anything times its inverse is just simply 1. And then what's cosine times tangent? Well, we got to remember that tangent is really sine over cosine theta. These guys cancel out, and boom, don't forget that parenthesis, boom, we're at our answer of 1 plus sine of theta, which is that side, and we are done. We've got some really interesting things happening up here, and I'm seeing this cosine squared on that -1 over there. And again, it's reminding me to look at this identity here. Now, if I subtracted 1 from that side, I get a cosine squared -1. Then I subtracted sine squared x, I would get a negative sine squared. So I can actually take these guys, and using that Pythagorean identity, I can just turn it into a negative sine squared theta plus tangent squared theta over sine squared theta. And again, look, there's different ways to do this. I'm choosing this as my way of evaluating this. There's other ways to do it, I'm sure. Then next, I'm going to break this up into 2 different fractions, right, which I'm allowed to do since I have that shared denominator. I can say negative sine squared theta over sine squared theta plus tangent squared theta over sine squared theta. Okay, this might not look very fruitful, but this is pretty good because this just becomes -1. And what's tangent over sine? Well, if I look over here, I can see that sine, if I look at this identity, I know that if I multiply by cosine, divide by tangent, I know that cosine equals sine over tangent of x, which means that if I flip this, right, tangent of x actually tangent over sine actually equals the inverse of that, which is secant. Another way to think about this is if I look at this trigonometric function, I multiply both sides by cosecant x. I have cosecant x times tangent of x equals secant of x. Cosecant is the same as 1 over sine, which means tangent of x over sine of x equals secant of x. Guess what? That's great news, because then I can convert this to secant squared x. Let's just rearrange it. Actually, no, let's leave it just like this. So -1 plus secant squared x. Well, that reminds me of this trigonometric identity. If I subtract 1 on this side, I have -1 plus secant squared x equals tangent squared x, and we're done. All right, next we have 1 plus tangent squared x over 1 minus tangent squared x, and we want to get it to equal this whole thing over here. All right, so 1 plus tangent squared x. Again, I'm reminded of this Pythagorean identity where I got a secant squared x. I'm going to start there, okay? So I'm going to say that this is really secant squared x, so that guy turns into secant squared over 1 minus tangent squared x. So that's a pretty good start. Then remember, secant squared is really 1 over cosine squared x. So I can rewrite secant squared as 1 over cosine squared x. I've simply thrown this down to the denominator, and this guy here is still going to stay the same, right? I got 1 minus tangent squared x. Now this is looking pretty promising, because if I distribute and I distribute, I get 1 over cosine squared x minus cosine squared x, and again tangent squared x. But I'm going to rewrite that tangent squared x, sine squared x over cosine squared x, because that's an identity that's perfectly legal. And then look what happens. Boom, boom, those guys cancel out, and I have 1 over cosine squared x minus sine squared x, and we're done. The first thing I want to do is I want to sort of dismantle this fraction, and I'm seeing a good opportunity for that if I multiply by the conjugate of 1 plus sine of x, which is 1 minus sine of x. So I'm going to multiply top and bottom by 1 minus sine of x. Okay, leave this alone for now. So now I have sine of x minus sine squared of x over 1 would be 1 times 1 is 1, negative sine of x, positive sine of x, minus sine squared of x. Now you might not think that means much, but that's pretty good, because look, now I got one of my Pythagorean identities I can reference, where I know that if I subtracted sine squared from this side, it would equal cosine squared x. So now I've got it over a nice single common denominator. I've got sine of x, minus sine squared of x over cosine squared of x. I still got my secant squared of x out there as well. Okay, now the reason why this is good is because if I got that secant squared of x over here, remember that's really, secant squared is the same as the inverse of cosine, means same as 1 over cosine squared x. All right, check this out. Now these guys have a common denominator. I can combine this and I get sine of x minus sine squared x plus 1 over a single cosine squared x. Okay, and then again, 1 minus sine squared x is the same as cosine of x, right? 1 minus sine squared x is cosine squared x. So we're going to go back here. Let me draw a little arrow up top. So now I'm going to change the 1 and the minus sine squared to a cosine squared x. So now I got sine of x minus cosine squared of x, plus cosine squared of x, plus cosine squared of x, because 1 minus that is positive cosine squared of x, over cosine squared of x. And now since I got two terms, I can actually split this into two terms. I can say sine of x over cosine squared of x plus cosine squared of x over cosine squared of x. Okay, last but not least, we're almost there. This becomes 1, of course, so that's where the plus 1 comes in. This becomes sine of x over cosine of x times that other 1 over, there's a second cosine of x. I'm going to throw that out here. Okay, why is that important? Okay, sine over cosine is going to give us our tangent. Cosine on the bottom is going to give us our secant, because 1 over cosine is secant, plus 1, and we have now just verified it. Number 12, we got secant squared minus 6 tangent plus 7 over secant squared x minus 5. I see that on this side I got tangent only. Again, I'm immediately going to that place where, hey, secant of x has an identity with tangent. And it says that secant squared equals tangent squared plus 1. So I'm going to just change these on top. This is the same as tangent squared x plus 1, plus 1 minus 6 tangent x plus 7, right? These guys are obviously going to combine, over tangent squared x plus 1, replacing the secant of x squared of x, minus 5. Okay, now let's kind of consolidate everything. So this becomes tangent squared x, 1 and 7 combined to be 8. I'll put that at the end. Why? Because again, I'm seeing a pattern with quadratics, minus 6 tangent x. Okay, over tangent squared x minus 4. So I'm seeing two things. One, I'm seeing this is probably factorable, just as if it were x squared minus 6x plus 8. And this is factorable because it's a difference of squares. So the top becomes tangent x minus 2 times tangent of x minus 4. Why did I choose those? Because those two multiply to positive 8 and add to negative 6, over tangent of x minus 2 tangent of x plus 2. That's how we factor a difference of squares. These guys cancel out, and voila, tangent of x minus 4 over tangent of x plus 2. Boom, done. On the left side here, we've got a very complicated expression. We want it to equal just a simple 2 cosecant of x. Your first thought might be to maybe multiply this by sine and multiply this by 1 minus cosine. But instead, if we again think about our Pythagorean identities, I'm going to take a route that I think is much easier. I'm going to multiply this guy by its conjugate. So I'm going to get sine x over 1 minus cosine of x times 1 plus cosine of x. Okay, and you're going to see why I did that in a second. I'm going to leave this one alone for now. The reason why is because, okay, this is going to be whatever, sine of x plus sine cosine. But this is going to be very interesting. This is going to be 1 plus cosine of x minus cosine of x. They cancel out. Minus cosine squared of x. And again, this uses this Pythagorean identity. 1 minus cosine squared x is actually sine squared x. So check this out. I got sine of x plus sine of x cosine of x. Probably shouldn't have distributed that sign, but that's okay. Over sine squared x. Now that is really, really helpful because all of these signs are going to cancel out, right? So this is going to cancel out to, well, it won't cancel out, turn to 1. That'll cancel out and that'll just turn into a sine. So down the left side becomes 1, right? That turns into 1. That just becomes a nice cosine of x over sine of x. And now look, they have common denominators. Plus 1 minus cosine of x over sine of x. These guys combine to 2. These guys cancel out. And I got 2 over sine of x. But when sine of x is in the denominator, it's the same as cosecant, right? 1 over sine of x is, oops, cosecant of x. And we're done. So in this one, I see 2 separated terms, and here I see 2 consolidated terms. My first instinct is, since this is, again, it's cosecant and secant, I get it, but I still want to get these into sine and cosine. So I'm going to do that, and I know that tangent of x is simply sine of x over cosine of x. And I know that cotangent is simply cosine of x over sine of x. And again, I already said, right, I want to consolidate these. I want to get them into one term. So I'm going to have a common denominator. I'm going to multiply this guy by sine over sine, which makes that sine squared. This guy by cosine x over times cosine on the top, which makes it cosine squared. Now I can consolidate this, and I got sine squared x plus cosine squared x over sine x cosine x. Remember, this is all in parentheses into the 4th power. What is sine squared plus cosine squared? Most important identity, as I mentioned before, that's 1. So it's 1 over sine of x cosine of x. And what is that? That simply means, what is 1 over sine? Cosecant. What is 1 over cosine? Secant. So this means cosecant x secant x to the 4th power. And of course, this to the 4th power is simply this. They just have like taken that to the 4th and that to the 4th, distributed that exponent essentially, and we're done. So in this one, my initial instinct is telling me I want to get tangent and cotangent in terms of sine and cosine, because I only got sine and cosine over here. So I got sine of x minus sine over cosine of x times cosine of x minus cosine of x over sine of x. And now I'm thinking maybe we simply FOIL. So I FOIL this and I get sine cosine of x, and then sine times that would be minus sine cosine x over sine of x. You can see those will cancel out, of course, which is nice. Then I multiply this guy, so I get minus sine x cosine of x over cosine of x. These, of course, cancel out, which is pretty cool. And then last but not least, I get this times that, which would be sine cosine. Let me see if I can, it'd be positive, of course. Sine cosine, oh boy, it's a lot. I'm gonna see if I can squeeze this in. Sine cosine on the top over, same thing, sine cosine or cosine sine on the bottom. And guess what? Cancel, 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 cancel. That's just 1. So now I have sine cosine of x minus cosine of x minus sine of x plus 1. Now this might not look like much, but this is actually factorable, and I'm going to show you how it factors. This, of course, becomes sine here and cosine here. Why is that? Because that would give me that first term. What gives me that last term? I'm going to say a -1 and a -1, right? Because that gives you the +1. I'm choosing negative because the middle two terms are negative. And check it out. If I refoil it, it'd be sine, cosine, minus cosine, which is right there, and then +1. And that's exactly what we have here. I just have the order flipped, but we are done. Okay, in this final one, the way that I'm thinking about it, I know we got a tangent squared here and a tangent squared there, but I'm still going to turn this in to sine squared over cosine squared and try and consolidate these guys. So again, if this is minus sine squared a, it's currently over 1. To get it to have a common denominator, I'm going to multiply this guy by cosine squared a over cosine squared a. Now I can kind of bring these guys together, and I have sine squared a minus sine squared a cosine squared a over a nice cosine squared. Oops, I keep saying theta instead of alpha. Now I can factor out sine squared a, and I'll have a 1 in there minus a cosine squared over cosine squared. Again, that really famous Pythagorean identity, sine squared plus cosine squared equals 1, aka 1 minus cosine squared equals sine squared. So now this is really sine squared a over cosine squared a. And the nice thing about this is sine squared over cosine squared just turns into tangent squared a. And we have verified it, and we are done. I hope you enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, please hit that subscribe button. If you have any problems in high school that you're struggling with right now in any of your math classes, feel free to send them my way, and I will do my best to turn them into an educational video to help you in these times. Thank you so much for joining, and I'll see you in the next video. Take it easy.